Hello, this is Saba, and I did Life Cycle of Stars for my Genius Hour project. How are stars created? Clouds of hydrogen and helium atoms left over from the Big Bang attract each other. These clouds are called nebulae. The atoms are pulled closer and closer to each other, making the mass denser and denser. This force of attraction that continues to pull the star together is its gravity. The atoms push outwards, so the combination of gravity and this outward push keeps the star from collapsing. And the picture is a nebula in space. So basically, it's just hydrogen and helium atoms. The life of an average star. A main sequence star is born just like every other star, through helium and hydrogen atoms condensing and hydrogen being converted into helium. The temperature at the core of these stars is about 10 million degrees Kelvin, and for the majority of their lives, they convert hydrogen into helium through nuclear fusion. And this is roughly what the star would look like. So you have hydrogen on the outside, and then you have hydrogen being converting into helium here, and then in the center you have a helium core. What happens when a star converts all of its hydrogen into helium? Once a star has used up all of its hydrogen and cannot fuse its helium into heavier atoms, it will turn into a white dwarf and then a black dwarf. So once it has used all of its hydrogen, then there's no more outward pressure, and the star will start to collapse on itself, and that's what the white dwarf is. And it has light coming off of it because of all the stored thermal energy inside of the star. Potentially, the white dwarf would become a black dwarf once all of its energy has been emitted and it completely cools. But since the stars in the universe have not reached that stage yet, there's no evidence that this will actually occur. It is all in theory. For stars that continue fusing helium into heavier atoms, such as carbon and oxygen, they will enter the red giant phase eventually once they are done fusing, as the particles emit energy and it becomes greater. And you can see here that it is much bigger than the sun. And then it could also become a planetary nebula, which is when the particles on the outside expand, or it could become so dense that it ends up exploding in a supernova, shown here. Life of a big star. Stars that have larger masses than the sun are born the same way than other stars, but progress more and die out differently. So if they have greater masses, then their cores will be more dense and they will be hotter, and they can fuse helium into carbon oxygen and then fuse those atoms into even heavier elements such as silicon and iron. So you would have the hydrogen on the outside, and then you could have helium over here, and that's the hydrogen that is fusing into helium. And then you would have helium fusing into carbon and oxygen, and then you would have silicon, and then Fe iron, and then eventually that becomes really dense and that stops, and then we get into how the star eventually dies. Neutron stars and black holes are produced from stars that are more than 20 times the mass of the sun, and the pressure is so great in their cores that the electrons and protons are pushed together, forming neutrons, hence the name. Neutron stars are so dense that a single teaspoon would weigh 1 billion tons, and these stars are about the size of a city. Eventually, the star will collapse into a single point of infinite density, and this point sucks in all of the particles and light particles around it, forming the circular black thing that you see in this picture. Thanks for watching!